In this lecture, we're going to provide a review of the shot put performance in terms of some of the techniques that are used to optimize performance that will eventually set us up for performing a quantitative biomechanical analysis. And so, if we examine the shot put in terms of the technique involved, an excellent paper published in 2001 provides a very good review of the different components of this athletic event. And so, as discussed earlier in this projectile motion unit, we discussed the importance of the release angle for optimizing the horizontal distance of the projectile. Some of the key distances, and so that we need to concern ourselves with here in terms of shot put performance, is the distance of the release. And as we can see, this is a very short distance. That's essentially the length of the block at the front end of the thrower's circle so that the athlete doesn't step over. So this is the boundary of the athlete's foot, and the release distance just reflects the width of that block. The distance of the flight is measured from the far end of the block to the point at which the center of the shot hits the ground. The landing distance is essentially the radius of the shot, as you can see measured here in this very short interval of length. And the officially recorded performance metric is taken as the sum of that release distance, which is the width of the thrower's block at the front end of the thrower's circle, plus the total flight, subtract the landing distance, which is the radius of the shot. So it's essentially where the front end of the thrower's block is to the near point where the shot put hits the ground. Now, as mentioned earlier, the release height is an important consideration, and so very often the release height in terms of developing a throwing technique in an athlete isn't always known, so it must be taken from some anthropometric measures of the individual athlete and possibly from video performance of their skill. But the release height is essentially going to be the sum of the athlete's shoulder height taken from the ground to their shoulder, and the release height is going to be a function of the athlete's arm length, the release angle, and that it's going to be the sine of that angle, which is the vertical component of their arm length. And so the other important characteristic here in determining the performance of how far the shot travels is, of course, that release height. Now, in terms of the factors affecting the release velocity and angle, there is certainly a relationship between that angle and the velocity of the release. And so there tends to be somewhat of a greater effect of gravity. Now, I put this in quotations because when we talk about gravity, it's the attraction between the shot and the earth, which is independent of the position of the shot relative to the thrower. However, if the release angle has a more vertical orientation, then the athlete will have to exert more force to take advantage of that, in order to take advantage of the need to move the shot in a further horizontal position. So the thrower must exert more force to counteract the gravity, which we'll see in this illustration shortly, if the interest is maximizing horizontal distance. So in this first example, here we see a release angle of 45 degrees. And in this latter example, here we see a little bit more of a shallow type of angle. Here the angle is less than 45 degrees. If that angle has a more vertical trajectory to it, more force and a greater release velocity must be applied in order to counteract that vertical orientation to achieve a better horizontal performance. And this is going to be related to the force-velocity relationship of muscle. And this is an inverse relation, so that with a faster velocity of movement, the force capability is going to be lower. On the opposite end of that, moving at a very, very slow velocity, we'll see an increase in the potential to generating maximum force or maximum strength output. So in our example here, in order to produce a greater force to achieve a faster velocity, if the shot takes a more vertical orientation, we see that in generating more force, that's going to have a diminishing effect on the velocity of the task, as opposed to producing less force, which would be necessary, which would be the result if the trajectory had somewhat of a more horizontal orientation. And keep in mind, this is related to the fact that the landing position is going to be lower than the release position. And so we see here that the velocity will be greater if the need to produce force is going to be less. And remember that release velocity is one of the three important characteristics in maximizing horizontal distance. So the release angle will also have, in and of itself, will have a very important effect on that horizontal trajectory. And so when we think about shot put performance, the optimal angle is that at which the projectile, in this case the shot, will generate the greatest horizontal distance or the greatest range. The optimal angle would be 45 degrees if the projectile in question lands at the exact same height than the release position. And so one example here is when the person acts as a projectile, for example, in the long jump. So in the long jump, the takeoff height is going to be the same as the landing height, so 45 degrees tends to be an optimal angle for the release. In that case, it's the takeoff angle from the board. The optimal angle is considered to be less than 45 degrees if the projectile lands at a lower height than the release position. And this is applicable to throwing sports, and in the example that we're using in this lecture is the shot put, where the release position is going to be a function of the shoulder height and the sign of the release angle and arm length. The optimal angle will tend to be greater than 45 degrees if the projectile lands at a greater height than the release position. And that's, in this case, the need to achieve a greater vertical trajectory is important, because that landing height is is greater than the height at which the projectile was released. So in these next two slides, we'll review two very common and popular techniques used in the shot put performance. The first is called the glide technique. And in the glide technique, here we see the athlete assuming a relatively crouched position as they prepare to move to the front end of the thrower circle. And the athlete would perform what's called a hitch kick, where the rear foot is pushed back in air. That helps them to achieve a forward whole body momentum towards the front end of the thrower circle. They engage in whole body angular rotation about the long axis in terms of the delivery, and then finally into the release and their recovery phase. So the second technique is referred to as the rotational technique. And as you can see here, at the start of this throwing technique in the preparation phase, the athlete takes on a more upright position as compared to the more crouched position in the glide technique. The very stark difference here is that the thrower will perform a whole body rotation in this manner as they move towards the front end of the thrower's circle and moving into the delivery phase and eventually into the release and recovery. So it begs the question, which of these two techniques are considered to be more advantageous? Well, if we focus first on the glide technique between the preparation and the release phase, what we see here is a much greater vertical range in the actual shot. So the shot is being held close inside, close to the athlete's neck, and the shot is released here at the end of the arm and hand. And so from the preparation to the release, we have a very large vertical range, which proves to be an advantage because this greater range affords more time and distance to accelerate the shot. And if that shot can be accelerated to a greater degree, it's going to achieve a higher release velocity. And that's important because one of the factors determining the horizontal distance is that release velocity. When we compare this to the rotational technique and examine the position of the shot between the preparation and release phase, we see a much narrower vertical range as compared to the glide technique. So we have less of a vertical range through which that shot will travel as the athlete prepares to throw that shot. And because of this fact, it raises the question of whether this technique will pose as a disadvantage to the performance. Not necessarily, because where the athlete loses that vertical range, the whole body angular rotation will generate angular momentum. And that angular momentum can be translated into increasing the velocity of the shot. And so the limiting factor, or rather the determining factor, of whether an athlete will select to use the glide technique versus the rotational technique becomes dependent on the agility of the individual athlete and their ability to spin quickly. If the athlete is going to rely more on pure strength and power to generate that velocity, they may select the glide technique. A more agile athlete with greater flexibility may opt to use the rotational technique and use their whole body to generate that angular momentum. So this ends this part of our projectile motion lecture.